Hello. Perfect. Yeah. Comes on, everyone. Let's start off. So last thing we have done friction ka theory. So let's do some problems. Let's start with the problem. Like I said, friction, right? As such, the theory wise, it's really not much. The main thing is finding the direction and the magnitude. Actually, that's the main thing. Once you got that, it is fine. So let's start with an easy one. And then slowly we will bump up the level. So we have a surface, friction is mu, there is a block of mass m. It is given speed u initially. Block is given speed u on a rough ground. Mu is the coefficient of friction. Now, one thing here, if only mu is given, generally in the problems, right, sometimes they don't give mu s and mu k. Assume mu s is equal to mu k is equal to mu. Okay? If that is not the case, they'll mention specifically mu s is 0.3, mu k is 0.1. If they don't mention anything and they just give mu k value, means it is the same thing. So the question is, find the distance traveled before the block stops. The distance traveled by the block till it stops. How do you solve? So in steps is NLM, choose your system, draw the FBD. अभी सिर्फ इतना ही difference है, when you're drawing FBD, you have to decide the friction का direction magnitude. Once you've done that, apply accelerations, find consideration between them, write equation, solve. It's exactly NLM problem once you write F ka direction and the force. Easy stuff. You can type your answers to here, co-host. Other scams on, someone is missing, who is bunking today. I extended the deadline till tonight, so make sure to give it. Because of the Raksha Bandhan, some people couldn't write. So I'll give you that benefit of doubt. So me being a very innocent physics teacher, I will accept it. Sabhavya. See, first thing, step one, draw your FBD. Now listen carefully. Huh? It's not difficult, but you see the words that I'm using. Block M, normal reaction, mg. How is the block going? Block is given velocity u to the right. So there is a slipping. So friction will be backward. Now here, see, you have to make a statement. Since it is slipping, are you getting? Since it is slipping, F is maximum. You should not write F is maximum every time. बाद में देखेंगे. You're getting it. You have to be 100% sure. Like, हाँ, ये slip हो रहा है. And how do you know it is slipping? Tell me one thing. When do you say two surfaces are slipping? This is again a very important definition. How do you know something is slipping? Two surfaces in contact are said to be slipping if there is a relative velocity. Yeah. Remember this thing. This is quite a useful definition we're going to use later on multiple places. So most people say slipping, slipping, but they really don't know what it means. You know what people think? Slipping matlab they think the body is at rest. Example, if you take A here, going with 2 meter per second. If you take B here, going with 2 meter per second. And let's say this is placed on the ground, which is at rest. If you see, A and B are moving, but not slipping. B and ground are slipping. So the misconception generally, people have is no slipping matlab rest mein hona chahiye. Not necessary. Clear? Now see, since the ground and the block are slipping, this is F maximum. This is the main thing, right? If you don't know it is slipping or not slipping, what are you supposed to do? Just write F. That's it. You can't do anything. That's it. These are the only forces. And we know F max is equal to mu into N. And N is mg, so mu mg. Accelerations. Backward. Newton's second law. N is equal to mg. F max is equal to ma. This is mu mg is equal to ma. A is equal to mu g. So what you got is a block which is going with speed u and the acceleration a backward. This will travel some distance s and finally stop. Now you tell me which equation will fit this. Final velocity 0, initial velocity u. We have to use v square minus u square is 2as. Kinematics 0, u square. Acceleration is backward minus mu g, displacement. So s is equal to u square by 2 mu g. Please check. I know I scribbled a bit, but I hope you got it. Right positive, left negative. That's it. There are only three forces acting on the body: N, Ng, and friction backward. Are you clear? So every time you draw an FBD, when there is a friction, be little careful. Have some fear. You should have fear. When you see certain words like distance, friction, there should be some fear. Like, okay, there is a chance I might goof this up, and read it carefully. And second thing, when you're drawing FBD of friction, never write F is maximum until unless you're 100% sure you slip over. You have to prove that it is slipping and then use F maximum. If you can't prove it, then you don't know. And we are stuck. Clear? Easy one. Any doubts on this? How to draw FBD? What is the meaning of that? What is the meaning of slipping of two surfaces? Anything you didn't get in this page, please ask. Cams on, everyone. Mehan, Anika, cams on. If your cams are switched off, I will assume you are eating red velvet cake secretly without giving it to everyone. और Belgian truffle भी चलता है. Next one, let's see the question. I'm turning the page. Neil, clear na? Vartika, Anika, Adrit, Arjun, clear? Niranjan, Ali, clear? Perfect. This is the actual question. We have a block, mass m, given speed u. This point is x is equal to 0. The coefficient of friction mu is equal to e power minus x. X is the x coordinate. E is that exponential. Friction is not constant. As you're going, friction is decreasing. Find u if block never stops. Meaning, देखो क्या हो गया? If I put x is equal to 0, friction mu is equal to 1. X is equal to infinity, e power minus infinity is 1 by e power infinity, which is 0. Means as you go into infinity, friction becomes smaller, 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 and becomes 0 at infinity. So find the minimum speed of the block so that the block never stops. Get this. This in the previous one, kind of similar. Only thing, calculus is involved here. For people who are forgetting, E is just a number, 2.713 exponential. In case someone forgot the integration, e power ax dx is 1 by a e power ax. So there, I'm even putting the integration for you in case you forgot. Now, Bikar, you got 2 minutes. Any answers? Give it a decent number. Step 1, draw the FBD, find the forces, get the acceleration. Once you got the acceleration, it is kinematics. Anyone confused with the diagram, please ask me. Let me help you. Step 1, free body diagram, mass m, normal reaction, mg, and initial speed is f, therefore it is definitely slipping. It looks obvious, but better you write every time. Acceleration backward. So f max is equal to mass into acceleration, which is mu into n is equal to mass into acceleration. Mu is e power minus x, n is mg, is m into a. Acceleration is equal to g into e power minus x. Acceleration is minus v dv by dx. Why minus? Because it is decelerating. A and B are opposite. So there's the acceleration part. So then we get v dv is equal to minus g e power minus x dx. Limits v dv, you are going from u to 0 because eventually you want it to stop at infinity. No, that's not the answer. Minus g integral e power minus x dx, you are going from 0 to infinity. Clear? Suppose, I can ask a question like this. Find the distance traveled when the speed becomes half. Limits क्या होगा? Find the speed when the distance in speed becomes half. So I will do more generally, okay? u to u by 2. So I will write v and I'll write x, okay? So v is the speed at x. So this is a more general thing. Instead of directly getting the answer, we are going a little longer, but gives you more information. So this guy will be v square minus u square by 2. I'm directly putting it minus g. So that will be minus 1. So g ho jayega wo. And e power minus x limits will go from 0 to x. So v square minus u square is 2g. E power minus x and e power 0 is 1. Be careful. Don't, e power 0 is not 0. So we get v square is equal to u square minus 2g 1 minus e power minus x. This is the velocity at a distance x. I didn't ask you this, but that is a more better one. And then what do you want at infinity? As x tends to infinity, we should be greater than equal to 0. So u square minus 2g 1 e power minus infinity should be greater than equal to 0. So u square minus 2g and 1 minus infinity is 0 is greater than 0. U square is greater than equal to 2g. U should be greater than equal to root 20 meters per second. Please check. Actually, if you directly put na here, u to 0, 0 to infinity, answer here pe aa jayega. I just took a long way to show you find the velocity as function of x. Because every time they won't ask you this, they can ask you find the distance when the speed becomes half. That means v is u by 2 whole square. So I can play around. Please have a look at this. Friction, loss of motion, kinematics. A little calculus. 3 chapters. This is how we will play the game. Whatever you learned, everything will keep popping up. Any doubts on this? Anyone not clear with this, please ask. You should get comfortable with this level of integration. I know 12th when they teach you, they'll do more dangerous ones, but at least right now you should be comfortable with this level. It looks scary, but actually kuch hai hi nahi tha. You should know your steps and signs and everything. Clear? Can I go ahead? Any doubts on this pitch? Aryan, clear? Vidyut? Yasha, clear? Swastika? Got this. Maulika? Ritu? Clear? Great. Abhinav, clear, no?
Yes.
Perfect. Next one. Let's do an easy one. We have a block, 5 kg. Mu is equal to 0.2. We have a force is equal to 20 root 2 at an angle of 45 degree. Find the distance traveled in 2 seconds initially at rest. So you have block on a rough ground, mu 0.2, and you're applying force at an angle 45. Find the distance traveled with the block in 2 seconds. Oh, Arjun, that's a pretty fast answer. You solved it. You know the answer already before.
Yes, sir. I mean, I've done like similar problems at PACE already.
Let's see. We have Mehan gave 28 answer. Yasha says 4. Itna fast aa gaya, you guys. Great. Aryan also got 28. So we have 2 28s and 2 4s. So some of you are definitely wrong. We have 2 28s and 2 4s. Anyone else wants to say something? I thought you guys will take at least a minute. Surprising. So pacemaker did the problem with the same numbers.
Wait, actually, my answer is wrong, I think.
We have 3 4s now and 2 28s. Try. I'll give you a minute. Again, remember, always the story is always the same. Draw an FBD, write the forces, find acceleration, solve. If you remember the basic algo, if you remember, I keep saying this like a broken tape recorder every time. And this is, the reason for that is I want you to drill this thing, what I'm saying right now into your head. Exam mein yahi aana chahiye. When you're stuck with a question, you should know what to do. You should not be staring into the sky as if, God is going to come and give you a revelation. Abhi chalo, ye problem aisa karo. No one is going to come and tell you that. We have one more 4. Okay, many people are getting 4. So chalo, I'll ask you one thing. Tell me whether you have done that or not. If you have taken n is equal to 50, you did a blunder.
Yeah, I did that first. But
So
then I got it.
people who took n is equal to 50, you did a blunder. And if you got 4 with that, it's definitely wrong. Answer, I don't know. मुझे भी करना पड़ेगा. I just got the numbers on some name. Anika got a weird answer, 28 by 5. We have 6.4, Arjun. But anyways, if you took n is 50, you did a blunder. Chalo, abhi karo. I'll give you a minute more. N is not Ng. Free body diagram. Forces, F cos 45, 20. F sin 45, 20. Weight, 50. Normal reaction, friction, maximum, वो पता नहीं अभी. This actually I don't know. So what is N? N is mg minus F sin 45. There is a vertical component there. 50 minus 20, N is 30 newtons. What is F max? Mu into N, which is 0.2 into 30, which is 6 newtons. Since F cos 45 is greater than F max, it will move. And now you say, therefore this is F maximum. So now you know this is F maximum. You're getting? You have to prove it will slip and then you put F maximum, or else you don't know. Since F cos 45 is greater than F max, it slips. How much is that? 6 newtons. Acceleration forward, 20 minus 6 is equal to 5a. Acceleration 14 by 5. You want distance traveled, S is equal to ut plus half at square. Initial velocity 0. Acceleration 14 by 5. Time is 2 square. 28 by 5 meters. Anika, you got it right. Adrit. Right. Venkatesh. That is wrong. Please check where you messed up. Yeah, 5.6 meters. The common mistake people do, they write n is equal to mg. Anyone not clear with this? Clear? Go ahead. Try. Found we. There is one thing, right? Last class, I had to add something here. We have something called contact force. Contact force is a net force due to surface. So here what will be the net force due to the surface here? N and F. So contact force will be root over n square plus f square. Be careful, huh? This mistake I did in the exam actually. Exam they said contact force is 40 newtons. I assumed n is equal to 40 and I solved the entire problem. Contact force is the net force due to the surface. So surface is giving n also, surface is giving friction also. I forgot to add this. Clear? Contact force, friction, normal are completely different.
So, but like when you said it's a smooth surface, we can directly take it as a normal, right?
Then it will be same. That will be same. Next one. Let's say a good one. We have a rough surface here, mu, and this left side is smooth. And we have a block here, mass m, and the length L. This is given speed u. So after this point, right, it is rough on the right side of the surface is rough and the left side is smooth. So initially it is given speed u. Find the distance traveled by the block before it stops. So after O, it is rough. Before O, it is smooth. So initially the block entirely is on a smooth surface. And after point O, it becomes rough. So how much distance will this travel before it stops? Get this. Adrit. Why do you think I'll ask you something so simple? कुछ तो गड़बड़ है ना रे. Left is smooth, right is rough. How will you get the same answer as 1A? So you mean to say this and 1A problem are exactly same? So that smooth and rough का कुछ मतलब ही नहीं है then. Think. I'll give you a minute. 2 minutes. You're taking it in a wrong sense. Friction is fundamental surface area, but is the is the entire area identical? So according to you, Adrit, let's say if you take a sandpaper and if you take a smooth cloth, if you take this and start rubbing your face, do you think that will be same as smooth cloth? Or if you take a full sandpaper, do you really think all three will be identical? Sandpaper will start bleeding, right? क्या gas था? Sure, I'll give you a hint. See. U square by 2 mu mg minus, well, I don't know. Let's see. What is happening? See. Let the block go inside the rough surface by x. Let the block travel x into the rough surface. Now you tell me, that means you're interested only in this part. The friction will come only because of the shaded part, isn't it? Why will you take full mass? You should take the normal reaction only due to the shaded part. The friction is only due to the shaded part. So it is like if one leg is inside and one leg is outside, shouldn't you take only normal on one leg? Won't the normal reaction divide between both the legs? See, if you're standing legs in both the legs, if your weight is 50 kg, each leg will take 25, right? The normal reaction is not full. The friction is only due to the shaded part. So if you just look this shaded part, this mass m will be m by L into x. Is that clear, everyone? Unitary method. If length L has mass capital M, if length x will be how much mass? M will be mx by L. So this weight will be small mg, this will be normal reaction, and this will be friction. So F will be equal to mu into N, and this will be mu into M G x by L. This is your friction. Friction is not constant. As more and more surface area enters, more and more normal reaction will come, and you get more and more friction. Please check. This is the main idea in the equation. Friction is not constant. Clear?
Sir, what if we do this with energy conservation?
You know how to do energy. If I didn't teach you yet. Do it now. Nothing wrong. You do it and you ask now. Why you want to throw your methods onto me?
Sir, I tried, but I'm getting this.
So then you have to wait till I teach you. So do this way, na? Use force methods and solve. So you want to solve with energy methods. Try the next question and tell me. How to do this thing? What else from here? You're done actually. So we got the friction here. So this part was the shaded part. We got friction is mu mg x by L, and this is your acceleration. Kinematics. F is equal to, now see, F is equal to total mass into acceleration. Are you getting it? Even though friction is acting only on the one part, but the acceleration is for the full body. So mu mg x by L is equal to mm cancels. We get acceleration is equal to mu g by L into x. Acceleration is minus v dv by dx. Again, minus because it is decelerating. If A and V are in the same direction, it will be positive. If A and V are in the opposite direction, put a minus sign. So minus v dv mu g by L x dx. So what is your final condition? Your final condition is this. The block is completely entered. This is the final speed. This is the initial speed. So v is the velocity when the block is completely entered. So limits will be from U to V. This will be from 0 to L. So this will be V square minus U square by 2 is equal to mu G by L. X square by 2, that will be L square by 2. From here I get V square is equal to 2 will cancel, U square minus mu G by mu G L by 2. This is the velocity when you have just entered the rough surface. Have a look at this page. Question is still not over. This is the velocity when the block enters.
Sir, can we take the mu from U directly to 0? Because it is
How do you know
stopping
it,
finally.
how do you know it is stopping?
That we have to find, no?
तो अभी वही तो कर रहे हैं ना. So you are saying U to 0 मतलब Adrit, once you completely enter friction क्या होगा?
Mu mg.
Then कैसे integrate करोगे?
But then the x is also L.
So acceleration कितना था?
Okay. Sir.
ना कितना था? Mu G. Then why are you integrating when A is constant? Got the point? Problem change हो जाएगा. Now see, after entering, what is the scenario? After completely entering, this is how the question looks. This thing will have speed V. The block will travel here and stops. Let this distance be S. Since it is slipping, friction is maximum. How much? Mu mg. It is constant now. And this is acceleration. So F max is equal to ma. You have to solve the problem in two parts, while entering and after entering. Mu mg is equal to ma. Acceleration is mu g. Since acceleration is constant, I can use the kinematics equations. V square minus u square is 2as. What is v square? हमने यहाँ पे calculate किया. So the final speed in the first part is the initial speed of the second part. U square. This will be v square minus 0. No, sorry. This is 0. This will be your initial speed. I'll do one thing. Wait. V final square minus v initial square is 2as. V final is 0 and v initial is this guy. U square minus mu g L by 2 is equal to 2. Acceleration is minus mu g and distance is s. So this will be u square. Minus will go off. The u square minus mu g L by 2 is 2 mu g s. So s will be u square by 2 mu g minus L by 2. But this is not the answer. So finally, how much did the block travel? Initially, block is here. Finally, block has traveled here. So initially, block has traveled L plus S. The total distance traveled is S plus L, which is u square by 2 mu g plus L by 2. So you have a traveled distance L on the smooth and rough surface and this much in the rough surface. Please check the steps. You have to do the problem in two parts. While entering, integrate karna padega. Once you have completely entered, acceleration is constant. Then you just start to use kinematics equations. Please just check the steps. It's a good one. These are the kind of questions you'll get in advance, maybe single choice. So the main idea there is whatever part of the block is in the normal on the rough surface, only that normal reaction is responsible. So when you get a confusion, think of like this. If you're standing with two legs, if this leg is on a rough surface and this is on smooth, दोनों का normal reaction half होगा ना, mg by 2 mg by. Why will friction be mu into mg total? It should be friction and normal reaction of the point which is on the rough surface. Please check this thing, everyone. Clear? Any doubts on this? It's a good one.
So it is possible that the block stops before entering the
Then क्या आएगा पता है? Then you will get b square is negative.
yeah. Okay.
Means you get an imaginary number. Saying the block won't even go till the enter the completely.
Mm.
So
Okay.
if that is the case, you'll get an imaginary number here. You'll get v square negative.
Okay.
We can add that. If v square is negative, implies block stopped in the middle only. It has not completely entered inside. So the problem stops there. Okay. Any doubts on this? Anyone not convinced with any particular step, please ask. Neil, Ali, clear with this? Sure? Ali, sure, no? Ansha, Aditya, clear? Adrit, got a mistake? Yasha, Abhinav, clear?
Yes.
Ritu, Vartika, Aryan, Venkatesh. Venkatesh, do adjust your camera a bit. I can't see you. I mean, I know you got a pretty good hairstyle, but it'll be good if we can see you. Meaning, I'm okay with it, but Mehan is complaining, sir, you tell everyone, but you know, we can't see Venkatesh ka face. Mehan is quite angry with you. See, he's smiling also pretty evilly. He's the one who's eating the red velvet cake. Next one. Going ahead. Easy one. We got a block. 2 kg. This is a wall. Friction is 0.5 and you're applying a force of 100 newtons. Find contact force. Gravity is there. Mm, 50 newtons. I'm getting a strong feeling that is wrong. Maybe right. Solve karna padega, but I'm pretty sure it is wrong. But we have one answer so far, everyone. We have 150. So exam में क्या हुआ पता है? They said contact force is 40 Newton. I took N is 40. And they also mentioned take G as 9.8. I took G as 10 and solved. I got 3.6. Integer question tha. So that time it was proper integer. There were no decimals. So I rounded off 3.6 to 4. My friends, they took N as 40. They took G 9.8. Unko 3.4 आया था. They rounded off to 3. Answer is 4. So contact force was N square plus F square. That is 14. N is not 40. We have 100. Interesting. T and 100. Anything else? 30 seconds more. This is an easy one. Come on. Steps are same. Always start with a free body diagram. Oh, Adrit got root over 10,400. Arjun got 20 to 51. I'm expecting answers in roots.
So even I got root 10,400.
So
Let's see. First thing, free body
it's
diagram.
that.
Start with the free body diagram. Mg, normal reaction, friction. How much is friction? I don't know. You always start with this word, I don't know. N is 100 newtons. F max is you have to prove it is slipping. Until then, you don't write F max. F max kitna tha? Mu into N, which is 0.5 into 100. That is 50 newtons. But if you see in the vertical direction, since F max is greater than mg, block won't move only. Remember that 1 lakh example I gave you? What is the meaning of this? I can give you 50 newtons, but how much do I need? Block won't move. So we just need 20 newtons to stop the block. We need F is equal to 20 to stop slipping. Why should I get 50 here? Therefore, F is 20 newtons. F is not 50. That is a mistake people do. You have to prove it is slipping. Then you write F max. If you don't know it is slipping, you prove it. Therefore, contact force will be N square plus F square. N is 100. F is 20 square. Root 10,400. Check. Yeah, right, Venkatesh. Vidyut. So be careful there. Don't write dumb every time F max करके मत लिखो. Every time you draw an FBD, be careful. Ask yourself, am I sure is this moving? Is this slipping? If your answer is yes, it is slipping, then put F max. If you say, maybe I don't know, matlab gaya. The moment you say, maybe I don't know, it is gone. You actually check the calculations and see whether it is moving or not, and then you come back. That is the whole reason why this friction has a separate chapter for itself. I hope this was clear. Easy stuff. This will be a proper mains level question. This is a mains or a bits level question, and this is why people goof up. It is not too tough to solve, but people have a conceptual problem. They will write F is 50 and they will do that. Or some people think contact force is N only and they'll goof it up. Or some people think contact force is friction. So be careful with that. Clear? Next one. Can I turn the page? Please stop me. Anytime you feel like if I'm going ahead, please stop me. But if there's no issue, I'm going ahead. Going ahead. Similar one, but little different. We have a 3 kg block. We have a 2 kg block. We have F. This is the wall. Here mu is 0.2. Here mu is 0.3. So two different frictions we have. So the question is gravity is there. Find the value of F. Find F minimum if both the blocks are at rest. No, none of them slip. If there's no slipping at any surface. It's like a book on top of a book and you're pushing it. So between 3 and the wall is 0.2. Between 2 and 3 is 0.3. Friction is different. Find the minimum value of F so that none of the blocks slip. Try. Try. Just give it a try and get some water and some. The answer is 150. Okay. 200 by 3. Let's start with the free body diagram. First thing, see, 2 kg का FBD. Force F, normal reaction. Your weight 20, friction has to be up. Let this be F1. Since it is in equilibrium, F1 is equal to 20. Now, be careful here. What is friction value? Less than or equal to mu n. Since it is not slipping, it should be less than or equal to mu n. I don't know. Don't write mu n. If it is not slipping, the friction value is always less than or equal to mu n. So that is 20 less than equal to mu s 0.3 into n. And n is nothing but f. So f should be greater than or equal to 200 by 3. So you know what is this thing saying? This is saying you give me 200 by 3, I'll make sure 2 kg doesn't slip. So this is a condition for 2 kg not to slip. Like I said, every surface will only think about itself. It doesn't care what the other surfaces are doing. Now look at the 3 kg ka free body diagram. This will be the same normal reaction. This will be n wall, which is again equal to f only. Now there will be two frictions here. F1 will act down, Newton's third law. This will be F2. If you're pushing 2 kg up, then you will push the 3 kg down and your own weight 30. So here you'll get F2 will be F1 plus 30. F1 ka value is how much? 20. So F2 is 50. This is less than equal to mu n wall. So 50 mu is 0.2 and n wall is again F. So this F should be greater than equal to 250 newtons. So this is saying, if you give me 250, I'll make sure 3 kg won't slip. Now you don't want 3 kg to slip, right? And you don't want the 2 kg to slip. Therefore, the minimum we require is, if F is greater than or equal to 250, no one slips. Got this? I can ask you like this also, na? Find the condition if 2 kg does not slip but 3 kg slips. क्या होना चाहिए? F should be between 200 by 3 and 250, isn't it? Are you getting? You have to take a combination of both the conditions. If I give 200 by 3, this guy is safe. If I give 250, this guy is safe. That means for both of them to be safe, I need to give 250. Please check. I think people who got 150 forgot to keep F1 on the FBD. If you're pushing 2 kg up with F1, then that F1 will push 3 kg down. Check this out. It's a good one.
Sir, in this, if the wall was smooth, would the friction in the blocks
Then
be
there
able
is
to-
no way, na? System kabhi bhi equilibrium mein nahi rahega. They'll
Oh.
definitely fall.
Okay.
There's no one to stop 3 kg, na? Think about it. F1 is also pushing down. MG is also pushing down. Who is helping 3 kg to remain at rest?
Yeah. Okay, got it.
It will definitely slide. All got this? Anusha, clear with this? Aditya, clear? Udian? Can I go ahead? Next one. Any doubts on this? Please ask. This is a good model. Huh? Again, proper mains level. Even in the mains level, this is a good one. 45 degrees, mu is equal to half. This is 10 root 2 kgs. We have a thing like this, and this is small m. Find m if the system is at rest. So you kept a 10 root 2 kg block on the incline, and the small m is hanging on the other side. It is not touching anything. Find the value of the small m so that the system does not move. Try. Got 2-3 minutes. Anika, that is an incomplete answer. Let's see how many of you will get this. This is a good one. Let's see. Right, Anika. Arjun got an interesting answer. So let me give you a hint. How many answers are there? That's a hint. It's not a single answer. Remember this thing. Whenever you hear the word friction and equilibrium or rest, it's a range. Telling you, right? You guys are underestimating friction का force. That's why you are getting a single answer. See what is happening. Let's take two cases, okay? Maximum case. Now, if the weight is so heavy, how will the blocks go? This will try to come down and this will try to go up, right? Then what should the direction of friction? Maximum, the block will try to slide up. The 10 root 2 kg block will slide up. So when you draw the FBD, if you look at the forces, this will be 100 mg cos 45, 100. This is mg sine 45, which is also 100. Friction will be backward maximum because you're on the verge of slipping. And the normal reaction is this. So n is equal to 100 and F max is equal to 50. Mu is given as half. and this will be the tension. So we get tension is equal to F max plus mg sine 45 is 150 newtons. So if you take this small block here, this will be the tension. This will be small mg. T is equal to small mg. So we get m ka maximum value is 15 kgs. If you apply anything more than 15 kgs, the system will go up. Then means you have a minimum case also. What if the block is too light? Then the 10 rupee kg block will try to slide down. Remember, direction of friction. You have to see what is the tendency of the block to move. So if the block is trying to come down, now what are the forces? This is 100. This is 100. This is normal reaction. The friction upar hoga F max. This is your tension. So this time tension will be 100 minus 50. 50 newtons. And if you take the small block, we get tension, and this is mg. So T is equal to mg and m is equal to 5 kg. So the answer is m ka value should lie between 15 kgs to 5 kg. Any value between them, you are safe. I'll give you a little more context. Listen. Look what is happening here. The maximum friction is 50 newtons. Again, understand one thing. Does this mean I should give 50? Does this mean 50? What does this mean? I can give you up to 50. Remember that word. Now listen. Let's say if I give you this scenario, देखो क्या हो रहा है. This is 100. Let's say this is tension. Now, for example, let's say if T is equal to exactly 100, friction कितना होगा? If T is equal to 100, what will be the friction? 0, right? If the string is automatically balancing, why should I give friction? Suppose if T is 110, then friction कितना होगा? 10 backward, na? Are you getting it? See, this is 110, this is 100. So you need a balance of 10. Friction will say, okay, I will give it to you. What if this is 120? Then friction will be 20. Are you getting what is happening? The friction ka value is changing. If I give 145, then friction will give you 45. So friction ka value is not constant. If this becomes 150, friction will give 50. Then it becomes maximum. Vice versa, I can do the other way around. Let's say given tension is 90 newtons. Then what friction will say? Okay, you're trying to go down, I'll help you out. So friction will say, I'll come up. How much? 10 newtons. If you say, so I'll give you less 18 newtons, then what will friction say? Okay, I'll give you 20 newtons to support you. If you say, I'll give you 60 newtons, then friction will say, I'll give you 40 newtons. If you say, I'll give 50 newtons, then friction will say, chalo, I'll give you maximum 50 newtons. If you go anything more than this, I can't give. Are you getting this, everyone? For different values of small m, the friction ka value will adjust. Friction ka value can change from plus 50 to minus 50. F constant nahi hai. Isn't this the story of friction initially? Depending on the situation, I'll give you how much you require. It doesn't mean I should give you 50 every time. Please take this. So you always take the extreme cases. If m is so heavy, the block will try to go up, friction piche lagega. If m is so light, the block will try to slide down, friction upar lagega. And then you get the maximum minimum value. So any answer between this is an answer. This question now will come in advance mein, multiple choice question. You know how they'll ask? Find the value of m if the system is in equilibrium. Options will be 2 kg, 7 kg, 12 kg, 13 kg. And you know, sabko kya lagega? If 5 is not there, 15 is not there. What happened? But you know, the answer is 7, 12, 13. Anything between 2 to 5 to 15 is an answer. Because most people will either do this or they will do this. But you have to do both. Please check. It's a good one. This question explains what is friction about. This is a very good question where, you know, friction changes direction, friction changes magnitude. This is the true nature of friction. And that's why it deserves their own chapter for itself. Springs don't do like this. They don't change direction in the middle. Tensions, masses, they do change a bit here and there, but itna drastically nahi hai. So among the forces, if you ask, friction is like a rogue. He is like the villain in the movie. Interesting villain though. It's like if you see that recent Shah Rukh Khan ka movie ka trailer, it is like that. We don't know whether he's a hero or a villain. Clear with this? Any doubts on this? Please ask. Next one. Can I turn the page? Palaksh, clear na so far? Ronak, all clear so far? Ronak there? Yeah. Ali, got it? Vidyut? Swastika? Clear na? Venkatesh? Clear? Anusha? Mehan? Clear? Next one. Any doubts, please ask. Don't hesitate, get things cleared. Let's say we have an incline theta, and this is mu is less than tan theta. The mu is there, it is less than tan theta. We have a block M projected with speed u. These are rough surface. Find ratio of time of ascent by time of descent. So what will happen? The block will go up. It will stop for a moment, then it will again slide back. Find the ratio of time of ascent by time of descent. This is a good one. And don't say it is 1. It is not. Next week we'll wrap up the chapter. We'll start circle motion next week. Maybe a little intro. And next week we have 2 classes. So we should be able to wrap up the chapter in 2 classes. But you're seeing this, right? The main thing is friction ka direction and magnitude. वो एक बार आ गया ना, then it is just loss of motion ka question. There's nothing there. But that getting that is only a headache. Direction and magnitude. Try everyone. This is slightly lengthy. Thoda hai working. Try 3 minutes. I'll give you. It's not tough. This is a question which is not tough but lengthy to solve. The previous one was kind of easy to solve, but it is little thoda sochna hai. That's it. Like I said, don't get confused between a tough question and a lengthy question. When you know question is easy but lengthy, that is fine. Yeah, that give you a kind of confidence. You just have to shut your mouth and solve. Should not be lazy for calculations. Mehan, Palaksh, put your cams back on. Palaksh, to adjust your camera a bit, I can't see you. Ritu, your cam is gone blank. Arjun, I can't see you. Venkatesh, please do something about your cam next time. You need to do something. There is one of your senior. I told him this one, do something about your cam. From next class onwards, he did something with the cam. It looks like, as if he's like a cat on top of a wall. It looks pretty weird. So don't do that, but do make sure I can see your face up to the chin. That is how I know you're not eating anything secretly. Venkatesh, do that. Do adjust next time. Palaksh, adjust your cam. The hand is not there. He went out somewhere. Is the acceleration same while going up and coming down? Same नहीं है. While going up, friction and mg sin theta both are in the same direction. While coming down, mg sin and friction in opposite directions. Acceleration gets messed up big time. So sin theta, mu cos theta, sin theta plus mu cos theta. ऐसा ही कुछ आएगा. It won't be a good answer. Let's see. You might be right, Ranika. Arjun. You also are right, I guess, but you forgot to put a root. Hey, everyone. While going up, mg sin theta, friction is maximum because it is slipping, mu mg cos theta. Acceleration is backward. So we have acceleration is equal to g sin theta, mg sin theta plus mu mg cos theta is equal to ma. I'm skipping that step. I'm writing the acceleration directly. This is the acceleration. So it will travel somewhere till here and stop. This would be the distance travel. So we can use s is equal to ut plus half at square. But s also I don't know now. To use v square minus u square is 2as. So v is 0. U is u square. Actually, I can use v is equal to u plus at. V is 0. U is u. A is this guy. Let's call this thing a1, okay? A1 time of ascent. So time of ascent will be u by a1. Keep that aside. Next thing, and I also know v square minus u square is 2as. You'll understand why I need this. V is 0, u square. This is 2a1s minus this is also minus a1. So the distance traveled will be s is equal to u square by 2a1. The reason why you need this is while coming back, how do you know? While you're coming back, u is 0. Do you think it will come back with the same speed? It will come back with some speed v dash, which I don't know. You're getting it? When it comes back to the ground, I don't know the speed, but I know the distance will be same. इसलिए s चाहिए था. And this guy would be mg sin theta. And this would be your f max, which is mu mg cos theta. And this acceleration will be a2. So we have a2 is equal to g sin theta minus mu g cos theta. So I can't use equation v is u plus at because I don't know v dash. I can't use v dash square minus u square. I don't know v dash. The only equation I have is s is equal to ut plus half at square. S will be this guy only, u square by 2a1. Initial velocity is 0. Acceleration is a2. And this will be time of descent square. So from here I get time of descent will be u by root a1 a2. And now you're asking me to find ratio of time of ascent by time of descent. I'll show it on the next page. So time of ascent by time of descent will be u by a1 by u by root a1 a2. So that is root over a2 by a1. So a2 by a1 will be g sin theta. G gets cancelled off sin theta minus mu cos theta by sin theta plus mu cos theta. Please check the steps. You need to find S also, because without that S second part, you won't understand what to do, because you don't know the final speed. Whatever distance you go up, the same distance you have to come down.
Return the page.
Please check the steps, everyone.
Sir, for this question, I took some values of theta and then brought the answer.
You shouldn't do that. You shouldn't do that. So tomorrow when you're working in a software company, you can't take some examples and say, na client ko aisa ho gaya. They'll kick you out. Don't do that. It doesn't work that way.
Sir, but if it would have been a multiple choice question, I could have.
You still can't do that. That is a very inferior way of solving, right, Mehan? That way, what will happen? Na? You'll never get a confidence like what to do. Maybe 1 or 2 questions हो जाएगा, mains and bits level तक. वो भी वहीं पे भी अटक जाओगे कभी-कभी. But telling you, right, you'll never get that confidence like what the hell is happening. Don't do that. Always learn with variables. If you're a medical student, you can do that. Are you a medical student by any chance? No, then don't do that. Medical people are eligible to do any nonsense. उनका कुछ भी चलता है. They तो do any great thing. Sin 2 theta is to sin theta. कुछ भी होता है उनका. I think recently what they did, this कुछ तो किया था ऐसा ही. Sin 2 theta d theta 2 sin theta d theta. I said, what the hell is this? You know what he said? ऐसा ही कुछ था रे, भूल गया मैंने. He said, sir, you only told me if there's a constant you can remove out of the integral. So don't become that smart. Don't use, but don't put variables. Clear with this? Any doubts on this? It's a good one. Next one. Try the next one with variables and see. We have an amoeba shape. And we have a rope. Uniform rope on the verge of slipping, meaning it is about to slip. So what a push kiya, it will go off. The coefficient of friction is mu. Height is h. The base is L. Find mu. So you kept a uniform rope on a rough, weird incline, which is on the verge of slipping. Look at this word, verge of slipping, about to slip. About to slip meaning friction is doing its best. So indirectly saying F is max. So keep that in mind. That is the word they will use, on the verge of slipping.
Is the rope massless?
Mass है ना, बिना mass friction कैसा आएगा? Uniform rope with some mass ले लेना.
Sir, and
Long time.
when the rope slips down, the rope collects at some point.
अरे मूव ही नहीं कर रहे गॉड.
अच्छा, okay.
मूव ही नहीं कर रहे. Find the on the verge of slipping, मूव ही नहीं कर रहे. उसको क्यों कलेक्ट करना है? Leave the rope at rest. Poor thing. It's sleeping. Don't disturb it. So let me say like a snake is sleeping on an incline. Why you want to go and poke it? Ever seen a snake? A proper one. You want to see more snakes? Join IIT Madras. Beside it, we have a Gindi park. We have a snake park. Bloody, you will find hundreds of snakes inside. There's a snake park. It just has snakes inside. King cobra, say python, say every damn thing is there. Tree snakes, water snakes. Snake Park. It came 3 times in my hostel. How do we do this? I taught you this thing in NLM if you remember. I told you something similar. Karke. 2 people left the class. Who are these 2 people? Why do people leave in the middle without informing? Palaksh. Who is the other one? Show you? See. Somewhere on the rope, take a small piece dx. And let this angle be theta. Theta is not constant, theta is changing. So you took a small piece of the rope, ds. So this can be treated as if it is on an incline theta. So this weight will be mu dm g. Dm is the mass of that small piece. Mu dmg sine theta. Friction is backward, that is F maximum because it's on the verge of slipping. Normal reaction is mu dmg cos theta. So F maximum is equal to, now here we have to be careful a bit. This is only a friction on this piece, okay? So total friction on the rope is equal to total weight component along the string. Now be careful here, huh? Don't write like this. If you write, what is F max then? F max is mu into n. So you can't write mu into n is equal to mu dmg sine theta. This is wrong. Can someone tell me why this is wrong? You know why this is, you know what you're assuming? We are assuming every piece of friction is balancing its own weight. Isn't that wrong? If you think about it, देखो यहाँ पे mg का component is only not there, but friction is maximum. Here friction का component is there, mg is also there. At different points, the friction and dmg sine theta will be different. If you write this, this implies, this means friction at every segment balances dmg sine theta of that segment, which is wrong. कोई guarantee नहीं है. Are you getting this? So what should be true? I'll just turn the page. On this entire rope, you have friction, 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 friction. And you have dmg sine theta, 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 dmg. So total friction F max should be equal to total dmg sine theta. The moment you put an integral, it becomes equal. Are you getting the difference between this and this? The total friction acting on the rope is equal to total weight acting on the rope. That is true. But the meaning of this statement is you're saying every segment of friction is balancing its own weight, which is wrong. Do you guys agree with that? Best example, इस piece का देखो scene क्या है. In this direction, there is no weight only. mg is downward, but friction is acting this way. It is not balanced. You getting this? So once you got this, so F max will be mu dn this dmg cos theta is equal to dmg sine theta. Gg cancels, don't cancel dm. Dm is nothing but mass by total length into ds. So mu into ds cos theta by L. This will be ds sine theta by L. LL cancels. We get mu ds cos theta is dx. This is dy. So when I took this small piece ds, this is theta, this horizontal is dx, and this vertical is dy. So this will go from 0 to L, and this will go from 0 to h. We get mu into L is equal to h. We get mu is equal to h by L. We got a pretty good answer though, independent of the shape. Please check. I hope you're getting the idea why this is wrong and why this is fine. The moment you put an integral, you'll get this thing. Actually, क्या हो रहा है ना? I'll tell you. What you're forgetting now, there's a tension here also. There are tensions in the rope also. That's the reason they're not equal. The upper part and the lower part are also pulling the string, na? That is the actual free body diagram, complete free body diagram. There are two tensions also. The upper part is pulling and the lower part is pulling, which we didn't draw in that. That's why these two are not equal. Now, if I write a more general formula for this, I'll write on the page. See, this is a more general form. So let's say if you have a surface like this, and if you have a rope like this. If this height is h1, this height is h2, and this length is L. If the rope is on the verge of slipping, this is important. A rope should be on the verge of slipping. Or else you can't take F max. The mu is given by the difference in height h2 minus h1 by L. This is the most standard one. It doesn't matter where is the height. You just take the two ends ka difference in height and finish it off. This is a more general formula, people. Let me show you how they'll ask this question. Clear? Let's see a question. So 8a, let's make it a part of this only. Let's say the semicircle. Hemisphere. And you have a rope here. This angle is 60 degrees. This angle is 30 degrees. It is on the verge of slipping. Find mu. Let's get this. This and the previous one are quite identical. It's a hemisphere of radius r. It won't matter though, but okay. Here. Root. Okay. See. So find the height now. What is this height here? So this is h2. That is 30. So this is 60. This is r. So this will be r cos 60, and this is r root 3 by 2. This is 30. So this will be r sine 30, r by 2. This is h1. And this will be r cos 30, r root 3 by 2. And we said, so from here to here, this would be your length L. So friction mu will be difference in height, h2 minus h1 by L. h2 is r root 3 by 2 minus r by 2 by length will be r by 2 plus r root 3 by 2. If you know this thing, you'll get the answer in pretty fast. Root 3 minus 1 by root 3 plus 1. Check. So basically, you just have to take the difference in height square, total length between the two ends, isn't it? So this end to this end ka length you have to take. So here I gave you some weird surface. Same thing, I gave a circle here. Check. L is the horizontal distance between the two ends. Clear? Next one. Easy stuff. This is a good one. If you remember the formula, it is pretty easy to solve, or else it becomes complex. Next one. Angle of repose. This is nothing. If you take an incline, and if you take a block, mass m, this would be mg sine theta, mg cos theta, and friction. If it is at rest, friction should be equal to mg sine theta. Be careful, never say f is equal to mu into n. And this should be less than equal to mu n. We get mg sine theta less than equal to mu mg cos theta. So we get tan theta is less than equal to mu. So as long as this condition is satisfied, there is no slipping. So angle of repose is defined as theta tan inverse mu. At this angle, this is called angle of repose. This is the angle when the block is about to slip. So angle of repose is an angle at which the body is about to slip, or F is maximum. So this angle is called angle of repose. So for angle of repose, you can also write tan theta as is mu. Mu is nothing but, you can multiply n and n. So this will become F max by n. So angle of repose can be also written as maximum friction by normal reaction. That's it. There is not a big deal. It is just an idea there. So sometimes they will say angle of repose is 45. So indirectly he's saying when tan theta, tan 45 is equal to mu, mu is 1, it will about to slip. So let's see how will they ask questions on based on this. I think you could have solved problems even without knowing this, but let's see. Please check. Clear? Going ahead. Now see, the simple questions would be sand cone. So they'll say something like this. A sand is poured. If you have gone to a beach, right? If you're putting a lot of sand here, if this was radius r, and this is radius h, and this is theta. So if you look at any sand grains here, if you look at the forces on them, this would be mg sine theta. So when it is on the verge of slipping, this will be F max. So we get tan theta is equal to angle of repose. Which is nothing but h by r. So the height of the cone maximum will be mu into radius of the cone. So whenever you're putting sand in a beach, right, the height of the cone, if you want to make it taller, without putting more base, you can't increase the height. That ratio of h by r will be always equal to mu. And because the beach ka sand is very smooth, right, mu is very less. So height bahut kam aata hai actually. But if I use something like clay, I can make it more sharper like this, because friction is high. So they can ask you based on this a sand cone, direct result. Second thing, insect walking in a bowl. So they will say there is a hemispherical bowl and that insect is walking. Now you tell me, if insect is walking, what's the direction of friction? Up. Because of friction, the insect is walking. Don't forget that. So F maximum, this will be mg sine theta. This is theta here. This is mu mg cos theta. Again, it is angle of repose. Insect cannot work more than angle of repose. Tan inverse, the maximum angle the insect can climb. All these are based on angle of repose. You could have written directly, it goes up to angle of repose. So height of a sand cone, insect walking in a bowl, these are different cases of it. Suppose if this bowl is not exactly spherical, you can also write like this. You can also write tan theta as dy by dx and find that y and x coordinate. Okay. Let's see a good question on this angle of repose. But look at this thing. This is how they can frame questions on this. Find the angle on the incline, or find the angle in a bowl, or find the sand cone, whatever. Clear? Now you try this question. Again, based on angle of repose. But let's see how much you remember. You have a hemispherical bowl, radius r, friction mu is equal to √3. Someone took some red colored dust, some red colored, dust is sprinkled on the hemisphere. Then what did we observe when you sprinkled, na? Sab dust nahi tha. A part of the sphere is covered in dust. And this is actually true. Because if you think about it here, right, it is too steep, particles will slide. So the particles are stuck only up to a certain height. Part of the sphere is covered in dust, the shaded area. Find the shaded area, or find the area covered in dust. Let's get this. Others, do keep your cams on. See? How to find area of an angle. That is something I taught you, which you forgot. First thing, let's find this thing. Up to what area is covered in dust? Angle of repose. Wo story common hai abhi. So up to angle of repose, that is the last particle which will stay there. After that, all will slip. So tan theta is equal to mu. So theta is 60 degrees. That is fine, angle of repose part. So abhi mujhe sirf ye area chahiye tha. And if you remember, I taught you how to find that area in calculus, which you don't remember. A part of a sphere, if it has an angle theta, the area is given by 2 pi r square 1 minus cos theta. Do you guys remember this now? Yatha integration. At an angle alpha, take a small piece, RD alpha, take a ring and then integrate the whole area. So this is the area covered. Dekho 60 degrees mein likha tha yahan pe. This was the problem. We did this for this one. So this is the result. I'll write it down. You can refer this. Refer page 115 calculus. So the area is given by 2 pi r square 1 minus cos theta. Theta is 60 degrees. So 2 pi r square 1 minus pi r square. If you know the result, answer will come in a step. If you don't know the result, you're stuck. You have to integrate. This is the area of a part of a sphere. This is the surface area of a part of a sphere. Please check refer. Huh? Don't forget to do that. Clear with this? And this result is important. Huh? It will again come in. Next, kahan pe aayega? Electrostatics to aayega. It will come in electrostatics, flux, ray optics mein aayega next. It will come in ray optics, electrostatics, and modern physics. 3 more chapters. Friction. So 4 chapters in total. Quite a good result though. That's the last one for the day. I'll give you some homework questions. Make sure to try them. Don't leave them. Try karke aana definitely, because they are good. They will take some time. Should try and come. Where are you? Kinematics. See, kinematics may loss of motion now. This would be your 10th one, homework. You kept a rod on 2 spheres and it is about to slide. Find the ratio of small r by capital R. Clear? This is one. The 11th one is even nice. This is pretty good. Everyone should definitely spend some time on these 2 questions, especially the 11th one. So if you spend 20 minutes also, it is worth it. You got a pulley here. We have a mass M1 and we have mass M2. So this is a rough fixed cylinder. Coefficient of friction is mu. Cylinder, it's a rough thing. So we have a rope like this. Remember, till now we studied all smooth pulleys. Kabhi friction wala pulley study nahi kiya humne. So this pulley has friction. This is a massless rope, but it has friction. Find M2 by M1. System is at rest. This will be proper advanced problem. Advanced ka bhi, it is on the verge only. Actually, it is a little higher only. Advanced problem there. 10th is still okay. 11th is pretty good one. Everyone definitely should try this and come. Next class, when we start, we are going to do these things. Clear? So try these 2 homework problems. We'll catch up next week. We'll continue from here. Mostly next week, we will finish a maximum of it. Thoda little spillover will be there. That will finish off next Friday. And next Friday, we'll start circular motion introduction also. Like I said, the chapter is really not that much as long as you know how to find the direction of friction and magnitude. Okay, so we'll wind up with this. Gravity is there. Find m1 by m2. Because of friction here, the system is not moving. Find m2 by m1 if the system is at rest. Okay, so with that, we'll wrap up for the day. So any doubts in today's class? Anything else you can ask me? Also free to leave. The test is extended till today night. What is the time? I hope everyone has given it. Anyway, it is there till night 11 o'clock, so make sure to give it. And the next test will be online on Saturday night or Sunday morning. I'll just keep it till 11 o'clock. Yeah, okay. So those are out, stay back, others can leave. First, any doubts in today's class you can ask.